And hello there, Cougar Academy Algebra 2. Welcome to lesson 5.5. Another awesome skill today. Get to teach you guys. How do you divide polynomials? All right, so get ready, buckle up for this one. It's a fun new trick for you, and we're going to eventually use it to solve polynomials and everything. So divide each polynomial below, write your remainder. Remember those terms with division as a fraction, okay? So let's take a look at this, and don't get scared. It'll be okay. We'll lead you through here. So division of polynomials is a bit different. We're going to start, and it's going to resemble looking old school division. So if you remember old school division, you'll be in good shape. If you don't, that's okay. We'll still get you there. So I'm going to draw my old school division bar here. And then out front, I'm simply going to have r minus 3. Okay? Hard job is done. It gets a little more challenging. Now, for division, the whole goal is this r. I want to think, what do I need to multiply in order to make it a 3r to the third? What do you need to multiply r by to make it 3r to the third? Okay? And the answer to that is we would want a 3r squared. So I'm going to write that up above there. 3r squared times r is going to make it 3r to the third. And once I decide that, that's exactly the process we'll utilize. 3r squared times r will make it 3r to the third. And then you want to distribute to the minus 3. So what we're going to see here is that's going to be negative 9r squared. Okay? Now the next step, this is an area where there's oftentimes a little trick here, so be careful with this first little curveball, is you want to subtract both of these numbers. So I'm going to draw this little bar here. Now I want to subtract both of these. So I call it a little sign switch. So I'm going to switch this to minus, switch this to positive, okay, and that takes care of the changing sign. So you might want to make note of that, especially since this is brand new, is to switch the signs. Don't forget, okay? When you do that, these should cancel your first term. So 3r to the third are going to cancel. Negative 10r plus 9r is just going to be an r squared. Okay, then we bring down the 9r. Okay, you always want to see how we have two terms in what we're dividing by. That means you want to have two terms here as well. Okay, and then we just repeat. So now I think to myself, what's going to make the r into r squared? Well, that would be a positive r. That's what I'm going to need to multiply by. A positive r. R times r is r squared. R times negative 3 is negative 3r. I'm going to draw off my bar. Don't forget to change the signs. Switcheroo. Good old switcheroo. And then those will cancel. That'll give me 12. And I'll bring down the 17. All right. And then we just finish this off. To make a 12r, we just need a 12. So I'm going to multiply by 12. That will become 12r. And then minus 12 times 3 is 36. And we'll go from there. And switch the signs. Switch the signs. Notice how I did that in different colors. If you want to use a highlighter as you go through these, I recommend that. And then we just have to take care of the 36 and minus 17. So I'm gonna, why not? I don't want to make any silly mistakes at this point. And that makes it 19. Okay. Now, the final answer, dun, 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 is 3r squared plus r plus 12. And the remainder as a fraction is going to be plus 19 over what we started dividing by. So that's what it means by write your remainder as a fraction. It's just what the remainder value is over what you are dividing by. So that's really all it is there. If you forget that little part, it's okay, but you're going to see when you check your answers that it's written as a fraction. So don't forget that last little trick there. And there it is, your first division problem. Might have been a little funky, but promise you'll get the hang of it as long as you practice. Okay, let's take a look at number 2, essentially just another practice problem. There's really no curveballs with this one. So if you want to pause and try it on your own, you can. I'm going to set it up here. We have m to the third. We have 2m squared. We have 32m and 18. And we have an m plus 5. Okay. And again, name of the game, how do I make m into m to the third? So that means I'm going to need an m squared. Distribute to both things. M to the third plus 5m squared. Switch the signs. Switch the signs. Again, I highly encourage, use different colors. Always try and make math a little more exciting for yourself. Use colors, okay, and go from there. So it's now negative 7m squared. Bring down the 32. Then we need a negative 7 and an m. So you want it to be exactly the same. If it's negative, you better multiply by a negative. That way, when you switch the signs, they will cancel. So be aware of that. Switcheroo. Boop, 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 boop. That makes it negative 3m plus 18. And then means we need a minus 3. So that's going to be negative 3m minus 15. Shakalaka. Change the signs. Pink this time, why not? And then 18 plus 15 is going to be 33. And there's your remainder. So the answer, all that hard work, m squared minus 7m minus 3, and this time plus 33 over what we started with, m plus 5. Okay, pretty easy stuff. Again, once you practice. I know you're like, Mr. Vorsey, it's because you've done this for a while. Again, you just got to practice, and it's a little tedious, but practice will make perfect. It'll build your math muscles. Yeah. Okay. Really, the rest of these, there's not too much else going on here. So, I thought there was something I wanted to point out. I guess not here. So try out 3. Let's see. Oh, 3 just has a 2 there. But really, it's not going to change too much. 2v to the third minus 8v squared plus 4v plus 17. And then 2v plus 2. So how do I make 2v into 2v to the third? I just need a v squared. Okay, so it's actually kind of a little nicer. And then plus 2v squared. Going to switch the signs. Switcheroo. Switcheroo. Minus 10v squared. Bring down the 4. Okay, and again, I know you might be operating a little slower pace, which is fine. You can watch the movie on slow motion. Whoa, I need to slow down. I don't need a 10. So to make a 10 from 2v, I need a 5. Aha! That's why I need to slow down sometimes. So mistakes are okay, all right? Of course, you just have to learn from them. Try and take your time, though, to avoid them. Add, switch the signs. So 14v, bring down the 17. And then lastly, I need that to be not 14 again. I'm doing the same thing. 7. 2 times 7 would be 14. And then 7 times 2 is 14. And I'm going to switch the signs. And that gives me 3. So 3 is our remainder. So v squared minus 5v plus 7. Our remainder is plus 3 over 2v plus 2, what we started with. Boom, 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 boom. So again, take your time. Let me double check that I distribute everything okay. To make it 10, I needed a 5. 5 times 2 is 10. Cool. And then it's 14. Alrighty, I think we're okay. Moving on then, example 4. I do want to make one little note here with 4. So it's really going to be the same idea. Let's pretend. Yay. Let's pretend that it actually is 64m to the third, and this term does not exist. Oh, man. Okay. So let's pretend that's the case. If this were the case, okay, what we'd have is 8m plus 4, 64m to the third. Now, in that spot should be an m squared, but there's not. So you want to fill in any m squareds with a 0. So you might be missing a term. If you're missing a term, you need to put in a filling. So missing terms, you need to put in 0. Okay, then we'd have minus 44m minus 2. Now this might throw off our answer a little bit, but that's okay. We'll just roll with it. So don't forget to put in fillings, and we'll see what happens. So to get to 64 from 8, I need 8m squared. 8m squared is going to be 64m, okay, to the third. And then 8 times 4 is going to be 32. Okay. Switching the signs, that's still going to happen. And it would just be 0 minus 32, or negative 32m squared. Okay, so nothing else changes. I just have that filling. Now, 8 to 32, I'm going to need minus 4. So 4m. So that will make it negative 32m squared. 4 times negative 4 is negative 16. And it looks like things will work out okay. Switch our signs. Plus, negative 44 plus 16 is negative 28. That's going to make things interesting. Negative 28 m minus 2. Okay, now, is there a way to go from 8 to negative 28 not cleanly, not without using a decimal? So we would actually have to stop here. So 8 cannot cleanly go into 28. So we would actually have that whole piece as our remainder. So since 8 has no factor, that goes into negative 28. So this one, we'd actually have to stop here. I know you could try and use a factor or a fraction, but since 8 can't go into negative 28, we'd stop. And then that would just be 8m squared minus 4m. And then that whole piece would actually be the remainder. So still a good idea for you to see this type of problem. I wanted to show you what would happen if you had some missing teeth, so to speak, in your problems. Okay, so that's division with little twist in the others. If I kept that 40, it would have came out differently. So you can always try that problem on your own. Last thing, so last example here. And this is dealing with what we call the remainder theorem. So there's going to be something special that happens here. Let's do division. So nothing else is going to change. There's a little sneaky thing at the end here, though. Minus 56, and n minus 7. Alrighty, so from n to 2n to the third, I need a 2n squared. 2n squared is going to make it 2n to the third. And then minus 14n squared. Going to change my signs. Boom, boom. 14 minus 9 is 5. N squared minus 27. And there's an n. Yes, I typed that in. I just needed, I was having a moment there. That's okay. Now we need a 5. So 5n squared. And then minus 35n. Let's see what happens. I change the signs. Negative 27 plus 35 is 8. Bring on down the negative 56. To get to 8, I need an 8 here. So that's 8n. And look at that, negative 56. Oh man, look how nice that is. Change the signs, we get a remainder of 0. All right, so the only little additional thing here is if you have a remainder of 0, with a remainder theorem, that just means remainders of 0 are factors. Remainders of 0 means you found a factor. Ooh, that's exciting. It'll mean more later. So essentially, 2n squared plus 5n plus 8, that's the answer, and it's also a factor. Okay, so with the homework problems, you'll have to decide, is it a factor or not? And basically, if you get a remainder of 0, it is a factor. If it's not 0, it's not a factor. So all those other examples we looked at were not factors, only that last one. So division, a new skill for you. Try it out, do your best, and great job as always.